Here's section 3.3. So at this point, we have talked about three different rules to find the derivative. We've talked about the power rule, where it's in polynomial looking form, where we have x's to a variable. We've looked at the product rule, where we've multiplied two functions together. We've looked at the quotient rule, where we've divided two functions by each other. Now we're going to take a little more drastic step into that power rule, or kind of an alternative form, I guess would be more of the word there, of a power rule. So what happens if we have a function now to an exponent? So we've already seen the power rule where we had maybe 2x to the fifth as our function, and we knew the derivative, or now we know the derivative is going to be 10x to the fourth, don't we? So what happens now, instead of just being a single variable to an exponent, maybe now we have a quantity to an exponent. So maybe now f of x is 2 times the quantity of x minus 3 to the fifth. So how is that going to change, and how do we find that derivative? So today we're looking at basic power, or basic chain rule, in which we have a function to an exponent. There are lots of different forms for the chain rule. Basically, all of them we're going to deal with, though, something about a function. So if h of x is a function to an exponent, we're going to find the derivative of that by taking the derivative, or the exponent, and multiplying it to the front, just like we did it in the power rule. So we multiply the exponent to the front. So we're going to bring the exponent to the front. Our function, though, is not going to change. So if you think about it, that x didn't change either, did it, in our power rule? So we're going to leave that function the same. We're going to decrease the exponent by 1. Very similar here as well. We decrease the exponent by 1. Here's where it's different. We're now going to multiply by the derivative of that function that we took it to the exponent of. So that's going to be the different part here, because we didn't multiply by the derivative. We could have, so the derivative of x in this case would be 1. So we could think of the power rule as a chain rule. It just doesn't make sense to make something more complicated than what we need to. So what does this look like in terms of examples? If we ask you to find f prime of x given this f of x, so 2x minus 3 to the fourth, the question always is, can I multiply 2x minus 3 to the fourth out? And absolutely you can. Those of you that love Pascal's triangle and the binomial expansion theorem, by all means, multiply it out. Use Pascal's triangle. However, the chain rule is going to allow us to clean up a little bit of that time and not make these so miserable for us. So what is our derivative going to look like? So here we're going to multiply the exponent to the front. Our function is not going to change. It stays the same. Notice up here, g of x does not change. We didn't do anything with it. We're going to decrease the exponent by 1, so 3, and then we're going to multiply by the derivative of the inside there, 2x minus 3, which is 2. The only thing we can really do at this point is to multiply these constants, couldn't think of the word there, 4 times 2, those two constants together to get 8 times 2x minus 3 to the third. And at this point, I would not ask you to multiply a quantity to the third out. It just becomes more work than we really need to worry about. We have bigger things to worry about, bigger fish to fry, they say. So, f prime of x here, we have negative 2. 3x plus 1 to the third is our original function. Can we find the derivative? Notice that negative 2 does not have a variable. So these are going to be nice, clean chain rules today. We're eventually going to put an x with that, which then we get a product rule and a quotient rule together. You'll love those. So here we're going to multiply that exponent, 3 to the negative 2, gives us negative 6. That quantity there is not going to change, 3x plus 1. We're going to decrease the exponent by 1, which gives us 2. And then the derivative of the function, don't forget that fourth piece to this chain rule. Derivative of 3x plus 1 gives us 3. Again, we can multiply those two constants together, those two monomials. If I can multiply 6 and 3 together, I would get 18, wouldn't I? So negative 18 times 3x plus 1 to the second. Couple more examples. These will be a little different. We're going to get some fractions in here. We're going to get some radicals. Oh, joy, joy, happy, happy. So, we multiply the 1/3 to the 3. That gives us 1. You can leave the 1 there if you want, or you don't have to worry about it. It's up to you. We have x squared minus 2. Again, that function does not change. To the negative 2/3, 1/3 minus 1 gives us negative 2/3, and then derivative of the inside, which is 2x. I am not going to allow for an answer on a test or a quiz to have a negative exponent within your answer. Depending on your professor in college, some will allow it, some won't. I like to make you clean it up. That way, if your professor does require you to, you won't be saying, "But Mr. Weaver, what did you do to us?" So, that negative exponent, how do we make a negative exponent positive? Well, we take it to the denominator of its term. So we have 1 times 2x, which is 2x. Those both have positive exponents, so they stay on the top. Our x squared minus 2 goes to the bottom, and our exponent changes to a positive. So we get 2x over x squared minus 2 to the 2/3. In our last example, we see a radical. So the first thing we got to do is be able to change that radical to an exponential. And from Algebra 2, you recall that we're going to take the exponent of the inside, that's our numerator, and then we're going to divide it by the index. That's the number that's in that little check marky looking thing. So we get to the 3/4. So our derivative, we're going to bring the exponent to the front, multiply it. There's a 1 there. 1 times 3/4 is 3/4. X squared plus 2. Decrease 3/4 by 1 gives us negative 1/4, and then derivative of the inside is 2x. Well, here we already have a fraction started. So we're going to take this negative exponent and take it to the denominator. Again, this is all one term. So we can take that to the denominator. We can multiply the 3 and the 2x also together as we do that. So we get 6x over 4 times x squared plus 2 to the 1/4. And at this point, I noticed that we have 6 times x over 4 times. So in multiplication, we can cancel common factors. In this case, 6 and 4 has a common factor of 2, doesn't it? So we can factor out that 2 and cancel them. We get 3x divided by 2 times the quantity x squared plus 2 to the 1/4. And that gives you an idea of what our chain rule is going to look like. We will spend several days on our chain rule. You're going to notice that we're going to put in the product rule and the quotient rule with these and do a lot more things with them. So stay tuned, I suppose. Good luck.